Hello, Professor. Thank you for joining my presentation. My name is Yamikani Chiwaula. This is my final project presentation for construction engineering and project management. In this presentation, I will walk through the major project requirements. So in this first slide, I just have a summary of the requirements, beginning with the cost estimation for Dallas site, which would be constructed 4 years from now, and the St. Louis site, which would be constructed 5 years from now. And in the second place, I have the precedence network diagram, the activity on node and Gantt chart, work breakdown structure, and then the early and late cost histograms, weekly cumulative versus cost versus time S curves for early, late, and target schedules, resource allocation, and leveling. And then finally, earned value analysis. This slide shows the cost adjustment for the Dallas, Texas site where construction is set to take place 4 years from now. We included a time factor based on a 3% compound interest. As you can see, that Dallas has slightly lower location cost index compared to Oklahoma City, but um, the Dallas building site and site area are larger. The size factor increases the cost after our adjustments um, and the 5% contingency. The total estimated cost for the Dallas project is approximately $4.57 million. And as you can see on the project management and procurement, I only used the location index and the time factor. I didn't use the size factor because it was kind of a problem to come up with it, but um, I think this works perfectly fine for the project management cost and procurement cost. And this slide summarizes the cost adjustment for the St. Louis, Missouri site, which is planned 5 years in the future. As we can see, St. Louis has a higher location index than Oklahoma City, which increases the cost factor. But the building sizes are smaller than the Dallas alternative, which reduces the size factor and overall cost. After adjustment and a 5% contingency, the estimated construction cost for St. Louis is approximately $3.61 million. So again, for the project management and procurement costs, I just use the time factor and the location index to come up with it. But as we can see, I've used 5% contingency for all of them for the adjustment of the two sides. This is according to my experience. I've seen that most projects use about 4.5 to 5% contingency. So I've just maintained the 5% contingency for both adjustments. So in the next slides, we'll be looking at the activity on node network diagram. This was developed using the MS project. So these diagrams show the logical relationships and dependencies among project tasks. The red path indicates the critical path. These are the activities that have zero float and determine the total project duration. The blue tasks have available float and some scheduling flexibility, and this diagram serves as the basis for determining early and late start schedules. So I have about 4 slides. They won't be very clear on the PowerPoint, but in the MS project, you should be able to see everything fully. So this is the continuation of the AON network diagram, and yeah, still another continuation, and it ends here. So the entire diagram can be viewed in the MS project files. Next, I have the Gantt chart for the entire project. So as you can see on the Gantt chart, the red bars indicate critical activities, while the blue bars represent non-critical tasks with float. The chart provides a clear timescale view of activity durations from project start to completion. This helped identify the earliest finish date before resource leveling, as well as visualize how some activities overlap in time. So this is the continuation of the Gantt chart again. The scale is uh, very big. So some may not be readable, but in the MS Project files, you should be able to find everything. And the other requirement was to make a work breakdown structure. So here's the work breakdown structure created for the project. Tasks are grouped under major categories such as project management. So I did the design, procurement, and construction as well separately. Um, this helped organize project deliverables and aligns them with the corresponding work packages. So this work breakdown structure also guides on how activities were assigned during scheduling and cost distribution. This is just the continuation of the work breakdown structure. I couldn't fit it all in one slide, and I hope it's visible enough. Yeah, but um, I think it should be uh, readable on the MS project file. So now I'd like to talk about two histograms, starting with this early schedule histogram. So this histogram shows weekly project costs based on the early start schedule. Costs increase steadily as more activities begin, with peaks during major construction phases. The orange cumulative cost line shows the progressive spending curve approaching the total project costs near the end. This helps evaluate the expenditure patterns and cash flow requirements. And the other histogram is the lead schedule histogram, which represents the lead start schedule. Compared to the early start schedule, you can notice some costs shifting toward later weeks due to increased float usage. And the cumulative cost curve climbs more gradually at first and rises more sharply towards the end. This schedule allows flexibility but may pose risks if delays do occur. In this slide, compares early, late, and target S curves. The early curve front loads the work and reaches the key cost milestones faster. The late curve shifts cost accumulation into later phases. The target schedule sits between the two and reflects a balanced plan for tracking performance. These curves are used for measuring progress and identifying deviations during project execution. So now we're going to look at resource allocation before leveling. So I just took a snippet um, of a date in 2026 between July and about August thereabout, um, just to see the changes before allocation and after allocation. So I took this screenshot within the same time frame. So as we can see, this chart shows resource usage before leveling. We set a limit of 30 workers, but as shown in the red portions, several time periods exceed the maximum resource availability. This indicates overallocation, meaning workers are scheduled for more labor than the limit permits, requiring schedule adjustments. So after applying resource leveling in MS Project, the schedule adjusts to eliminate all the overallocations. The red bars disappear and all resources now fall within the 30 worker limit. This process extends the project duration, resulting in a new project completion date of April 26, 2027, as documented in the project report uh, on the files that I've uploaded. So finally, we have the earned value analysis. So in this slide, I've just summarized the earned value analysis as of October 30, 2026. As we can see, the budget cost of work scheduled or planned value is approximately 2.58 million. The budget cost of work performed or earned value is $2.31 million, and the actual cost is about $1.97 million. So we can see the cost variance is positive, meaning the project is under the budget, which is a good thing. However, the schedule variance is shown in red in the Excel file, which means negative, indicating that the project is behind schedule, which is not necessarily a good thing at the moment. And we have the CPI of 0.89, means we're spending less than planned, and the SPI of over 1 suggests work is being completed slower relative to the schedule baseline. So in conclusion, this project required applying cost estimation, scheduling, um, resource management, and earned value analysis skills. We compared alternative locations, built scheduling diagrams, produced cost and resource histograms, and performed performance analysis. Through this process, I identified project risks, resource challenges, and timing impacts. And I can say overall, the project provided practical experience with tools and techniques essential for construction engineering and project management. Thank you very much for your attention, and thank you very much for teaching us this content.